Here is a Fosi audio Phono preamp. It's a box X2. So this is the early model, but it's I think it's better because the circuit is much simpler, which actually help you to further improve the performance. So in this video, I'm going to show you how I modify this Phono preamp to make it work better. In general, you can see a lot of reviews on this one. It's quite popular. One of the reasons is actually the tubes they use at the buffer stage. Later on, I will show you actually how you bypass it. Actually, that might be a better thing to do. I will explain why. So, first thing first is to remove these 4 screws in the front and 4 screws at the back, and then we can pull out the internal circuit. Before doing that, we want to remove the tubes to prevent damages. So here's the internal board. So pay attention to one of this wire. This is screw onto the knob of this switch, basically switch between gains and on and off. So this is ground, this case, the switch case. Now, before we go to the detail of the modification, let's first explain what we have here. So you can see here is a kind of a 12 volt DC input, and through this section of the circuit, it provides plus and minus 12 volts to all the op amps. So now we can see one of the benefits to use this preamp is that all these op amps are socketed. So you basically can change whatever op amp type and swap op amps very easily. This is one of the benefits. So the original come with the 68D, which is a very good op amp for Phono stage, so I didn't change it. So you can see here is the input, left, right input, goes through the op amp to do the equalization, the RIAA, and then come to this section. This is the aux input, so in parallel, you see this is output from the preamp. You can see the traces, and these are the coupling caps. They use the film cap here, and these are the resistors to do the gain control. And this is the output preamp, op amp, and then the output capacitors. So one of the things they use the tube is, it's very simple because it only provide 12 volts to the tubes. So it's not a functional tube. What they do is they heat up the filament, and then just use the gate and the screen. This tiny current flows through that gate and the screen, so that it can pass through the signal. So I wouldn't say it's really a kind of tube buffer. It's just pass through the tube, a small current through the tube. So that's the reason I don't like it. So I will show you how I bypass the tube, but I'll still let the tube to lie down. Just make it visually pleasant. So basically sometimes visual and the audio, it's a good combination. The reason a lot of people hear good tube sound, maybe they just see the tube light up. That's something I think I want to just keep it. Now, for the modification, So this is the main part of this video, because when I search YouTube, there's almost no modification, all reviews and so on. And there are maybe one or two modifications, but they require membership. And I don't know what they're modifying. So what I'm trying to do here, okay, let me introduce. So you can see the input from this side and this side pass through the ceramic capacitors. So ceramic capacitors considered a little bit noisy in terms of load signal sources. So ideally, you should replace them with some field capacitor. But the room here does not allow, so I didn't do it. I just let this one go. And then it come into these 2 amps for 2 channels to do the RIA filter, right? Equalization for the phono stage. Now the key part is the output of the through the side here. You see there are also ceramic capacitors, 1, 2 for each channel, 1 for each channel, and come into here, and then you see a serial resistor and then parallel resistor to adjust the gain. But before the series, after the series resistor, you can see they have film capacitors. So basically you're passing through 2 capacitors, ceramic capacitor, resistor, film capacitor. This is a bad thing. You don't want to do it because ceramic capacitor is relatively noisy, and 2 capacitors in series also a not very good thing to do. And I think the reason they do it is because they use this aux input to avoid the short of this output, DC short of this output of the op amp. But I will not use this. So the thing I did is, you see, I used solder just short the capacitor. So basically these capacitors no longer in the path, it's shorted, goes directly through into these film capacitors. And now the output of the field capacitor go to this buffer op amp for 2 channels. One go to this tube, the other goes to the right tube. Again, at the input of the tube, they have these film capacitor in parallel. So here we need another modification, is that, as mentioned, I don't want the tube to be in the path because it's kind of fancy, but it doesn't really give you the tube sound. It's just a very low current electron flow. There's no buffering, no amplification, whatever. So the way I bypass this, you can simply just disconnect the power. But if you disconnect power, the light and the tube filament, all those things will not light up. So I want to keep them light up just for fun. So the way I did it, you see, if we zoom in here, I cut the trace off so the signal won't go into the tube. Similarly, on the left-hand side, I use a sharp knife, cut the trace between the resistor and the capacitor. It's very tiny trace. You just use a sharp knife and slightly cut it. Don't work too hard on here. Just disconnect the input to the tube. That's totally fine. So now this thing will go through these film capacitors, but doesn't go through here. So we need to bypass this. You see on the back, you can see, you see there's 2 capacitors in parallel here, 1 capacitor in serial. It's about 1 microfarad each. So the output is 1 microfarad. It's kind of small. I will use these 3 in parallel as an output capacitor, give us about 3 microfarad, which is much better. So the way I did it, you can see I connect the capacitors in parallel. And by the way, you need to disconnect the output from the tube. You see on this leg, there's output from the pin of the tube. I again use a sharp knife to cut it off, so there's no connection to the tube. You want to do it the same on the left hand side too. So here is, you can see, is where I cut the trace from the tube output. So now once we connect the capacitor in parallel, basically we have the signal passing through these capacitors from the output of the op-amp through these capacitors to the output of the RCA output. Hopefully you can understand. I don't have a schematic, but it's quite simple, right? If you understand how op-amp operate, if you search the 26AD op-amp, you can find the pin function. You can easily figure out what the circuit is. It's very, very simple circuit. These large capacitors are just power supply filters, so nothing special. If you do, as I said, use knife to cut off the input and use knife to cut out the output. The output is a little tricky because on one side it's on the opposite of the board, and on this side it's on top of the board. So you cut out here and then you flip it over and cut out here. So now we very much complete the entire modification, and you still have all the functions. You still have the tubes light up, very nice and fancy, particularly during nighttime. So this is a good thing. But the idea is that utilize the equalization part, utilize the op-amp buffer and amplification, and the gain control, so that you can have a very nice little solid state preamp, phono preamp. But I believe the quality of the part used will give you a pretty good phono preamp. I use it, I will show you later on to play on my turntable and hear the sound. Thank you. So now we put it back, and you can see the tubes light on. Turn it on and put selector in the middle, 42 dB. It goes through this passive preamp and come down to this audio research power amp. So let's give it a try.
My first love.